My dear people, this is a very interesting problem. Here we have a tank 1 in which there is some liquid and the liquid is rushing through this pipe that is 20-meter long and diameter 0.2 meter into tank 2. The elevation of tank 1 and tank 2 are given, yeah, and they are also giving that there is some loss that's happening in the water because of the bend, the purple color over here. So the water is just losing some of its energy because of the bend. What else do we know? We have been given that the density of the liquid, it's not water, is it? The density is 1320 kilogram per meter cube, and also the friction factor in the pipe is 0.001. That is the friction that is happening. We have also been given that K entry, otherwise the entry loss is 0.5 and the exit loss is 0.4. Yeah, they are asking us to calculate what would be the velocity of flow in the pipe. They are not asking what is the velocity at section 2 or at section 1. No, they are asking what would be the velocity with which the fluid would be flowing through in the pipe. That is what they are asking. Yeah, that is what I've given. C pipe is not C2, so please don't get confused. Yeah, okay. So how to solve this particular problem? The go-to equation for us is the Bernoulli's equation. So I put in the Bernoulli's equation, yeah, and since there are some loss, I've just added it as head loss, yeah. So P1 by rho g plus C1 square by 2g plus Z1 equals P2 by rho g plus C2 square by 2g plus Z2, and with the head loss, yeah. So here we can easily simplify Bernoulli's equation. Think of it, in section 1 and section 2, they are both open to the atmosphere, which means that the pressure is atmospheric pressure. So we can cancel them out. Yeah, and similarly, the velocity with which the liquid is going to go down, yeah, and the velocity with which the liquid here is going to rise up are very small compared to the velocity in the pipe. Yeah, so I'm writing C1 is approximately equal to C2, which is approximately equal to 0 meters per second. Yeah, so we can easily cancel P1 P2 C1 C2 in the equation. So what do we have? P1 gets cancelled, C1 gets cancelled, P2 C2 gets cancelled. So we have Z1 equals Z2 plus head loss. So head loss is going to be Z2 goes to the other side of equal to sign and becomes negative. So Z1 minus Z2, which is 8 meter. So we have found the head loss, but we have got to find the velocity in the pipe. The formula, my dear people, for head loss. So what is head loss? Head loss formula is very simple. It is c square by 2g, which is nothing but the kinetic head. Yeah, look here, exactly here, c square by 2g times, yeah, the friction factor times the length of the pipe divided by the diameter of the pipe, yeah, plus all the losses, sum of all the losses. So what are the losses that we have here? We have the entry loss, exit loss, and we have two bend, 1 and 2. So these are the losses. So if I add them all together and substitute in the equation, so entry loss is 0.5, exit loss is 0.4, and bending loss are 0.1. So I get a value of 1.1. All that I do is I just substitute everything that we know here. We know HL from here. We already know the friction factor. It's given, the length is given, the diameter is given, sigma K, the sum of all the losses we have just found out. The only unknown is C square. Yeah. Well, C is the only unknown. If I substitute everything and rearrange the equation, I get the velocity to be 11.43 meters per second. Otherwise, the velocity with which the fluid is going to flow through this particular pipe is going to be 11.43 meters per second. Yeah, it is so very simple, is it not?